Somewhere around here, we've got video game programming. And if you're a computer scientist and you're interested in AI, you can't get away from video games, right? Because these are our simulations of the world to some extent. And that's kind of what Assignment 8 was about. So there's a big thing to do there. Okay, over here in the realm of learning, we studied decision trees. We touched upon neural nets, and I'm telling you, that's the picking up model. That's the model to study if you really want to know all about machine learning. But there's also a lot of reinforcement learning. Reinforcement learning. Q-learning is just one type of reinforcement learning, by the way. And these are now being tied to neural networks. There's a whole bunch of connections here that really need to be all kind of tied together in all kinds of different ways. But yeah, anyway, I'm suggesting you learn about neural nets. There are, of course, lots of other learning models, such as support vector machines, rule-based learning, naive Bayes, or Bayesian graphical models are a good system. And this is a very statistics-based approach. As we get over onto the learning side, you'll find that statistics plays very heavily into the models. So if you know a lot about statistics, you'll be very strong on the learning side. Although that's kind of true over here too. There's still a lot of statistics involved in utility theory and decision making. So I guess I should probably move statistics over. Statistics is kind of everywhere. We'll just draw the great big wrapping, enveloping circle for that one. Okay. If you study neural networks, the other type of math you're going to need to know is linear algebra. And diffie-q just a little bit. Differential equations, although not so much. A little bit of that, but a whole lot of linear algebra and a little bit of statistics. And statistics ties into kind of all of these techniques tie into all of it. The more math you can get, the better. If you're going to go into AI or machine learning or anything like it, math, math, math. Take all the math you can. I know you don't like math. You know why you don't like math? Because anyone that can do math is not teaching it. Right? The people that love math, they work for NASA. They work for companies. They're building awesome stuff. Anyone that ends up teaching math hates it. And the result is, math is miserable to learn. I'm sorry, go teach yourself math. If you teach yourself math, you'll realize it's the most awesome field out there. Math is the foundation of everything. So go math. All right. Let's see. In the domain of learning, we do regression, which has to do with predicting continuous values, and classification, which has to do with predicting categories of things. But there's a very similar thing to regression called time series prediction. And this is very important in lots of businesses that want to know what's going to happen next. If you're doing stock market prediction or supply chain management or anything that deals with time series prediction is pretty important. It's also an understudied area of learning, I think. And so I predict there's going to be a whole lot of job openings and a whole lot of importance in time series prediction in the future. We've so far studied a whole lot of static regression and classification. These two domains are almost studied to death in machine learning. But systems that change over time are really hard to get at. They're starting to be brand new. So I think there's going to be they're not new, but they're starting to be understood for the first time. So I imagine there's a lot to learn in time series prediction that would be really good for you. Okay. In the learning domain, there's audio recognition, facial recognition, any type of perception, right? Anything that involves what is this? You could do sonar detection or LiDAR recognition if you wanted to get into Navy or government missile guidance or things like that. There's a whole bunch of domains there that you can study. In fact, slightly related to that, there's something called, has anybody ever heard of control theory? Well, in control theory, you study methods for controlling systems, such as autonomous vehicles, or I'll just say UAV, unmanned aerial vehicles. As UAVs are becoming increasingly cheap and increasingly popular, Amazon's starting to look into those as delivery mechanisms. Maybe you'll have UAVs carrying your next hamburger or your next prescription medicine to your door. Autonomous vehicles are becoming increasingly used as delivery mechanisms. Some of the big merchants are starting to use unmanned vehicles to deliver groceries to your house. You can totally see the future in that, right? When a robot suddenly brings the groceries into the door. Okay, of course there's household robotics, and eventually we're going to want robots mowing our lawns and vacuuming our floors. We're kind of already there. But we're going to want robots cooking our meals, aren't we? You can get Amazon to deliver stuff instantly. We're really just one robot short of having a meal made in your kitchen from the groceries that you've purchased. And you can see all kinds of things going on there. Related to time series prediction, there's all kinds of stock market trading and marketing. And in this perception, there's trying to figure out what people want based on what they post on social media, scraping the internet. I should probably put data mining up here. These days, half the companies in the world are mining all the information off of the web. They're scanning your license plates wherever you drive and collecting your map data. And every time you visit a website, they're storing it. Why? Because they want to understand what's going on. And there's money in mining the data for value. Okay, let's see. Somewhere around here, I got to put fraud detection. Fraud detection is a type of perception because you're trying to understand when an intrusion has gone into your system. And then there's a whole bunch of security involved in AI. Somewhere over here, we got to put natural language processing. The more words are getting onto the internet, and the more we can recognize what people are saying, the more we want to understand what they're saying. NLP is sort of a type of perception. It's tightly connected with deep learning these days. But it's going to become increasingly important as humans are starting to talk to their machines and we're starting to tell them what's going on and what to do. Let's see. Closely tied to control theory is something called system identification. This is where you basically try to learn to model the system itself. This is sort of what goes on in your head when you watch the world and then you start to understand it and you make sense in your head. You basically build a model of the world. Well, system identification treats a system, like the world, as a complex thing and tries to understand its dynamics. I guess I should put dynamics up here, as that's a whole. Although, in fact, dynamics and control theory and system ID are kind of more over here in the decision-making realm. Let's see. There's analytics that's closely tied to data mining. That's all that pops into my head right now. But the impression I want to give you is there are a lot of spin-offs here that we just didn't even have time to cover. And if you were to crack open any artificial intelligence book, you'd find chapter after chapter of topics that I didn't even touch on. I just wanted to give you a foundation in this class. This is a field as big as your major. Computer science is kind of big, but a lot of universities are starting to have an artificial intelligence major. Some are even doing just a machine learning major. The field is really that big. There is so much to learn in artificial intelligence that if you think you got a good foundation in this class, you got a tip of the iceberg introduction to it. There's a lot going on, and if you really enjoyed it, I hope you'll study more topics. There's no way you could even know which one you want to do with the rest of your life. Just pick one. Start studying and see where it takes you. The more you start to learn these methods, the more you'll start to realize that you picked wrong and you hate it and you want to do something next to it. And you'll kind of follow one of these chains. It starts here and goes down somewhere and wanders around, and finally you'll find your calling in life and you'll decide that's what you want to study forever and become an expert in something, and you'll be highly paid for it. All of these domains are in huge demand right now. If you become really strong at just one of them, you can make a career out of that. There's a lot to be done in artificial intelligence, decision making, learning, and hey, ultimately, the big reason we want all of these things, of course, is because why? We want to take over the world. Mwah, ha, 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 ha. And eventually we're building our own replacements, aren't we? And isn't that the goal of every field, is to replace the need for themselves? I mean, consider a doctor that said, well, there's a cure for this, but I'm just going to treat it because I want to keep getting paid every time you come back for a treatment. That would be evil, right? Okay, well, this looks a little bit evil. Maybe I should get rid of the evil connotations there. But it's kind of the moral obligation of every domain to obviate its own need. Imagine a lawyer who tried to stir up trouble. That would be bad lawyer, right? Whereas a good lawyer is going to settle problems and cause there to be less need for lawyers. Imagine a media industry that instead of producing media, started trying to lock down on its distribution instead of helping people have media. Do you see how there's kind of a good side and a dark side to every field? And the good side is when you're trying to eliminate its need, and the dark side is when you start trying to make artificial need for that field. Well, the more we build artificial intelligence, the more I think what's really going to happen is we're going to start having brains. We're going to have artificial humans to some extent. Don't you agree? Now, maybe not really. Maybe the humans themselves will become artificial. Remember we opened this class by saying, are we not cyborgs already? And so every improvement we make to these machines, isn't that an improvement to ourselves? As we carry them around and use them all day long, and the things I put on my phone I can offload from my brain. I don't think we're really replacing humans or taking over the world. I think we're making humans better. And if you think about how humans compare to humans without technology, we're totally not even the same species, are we? I mean, we're so different from humans of 200 years ago that evolution really seems to be taking a surge in a completely different direction, and has clearly got to do with all of this stuff. So I hope you can see there's a lot of value in artificial intelligence, and a lot's going on, a lot more to study, a lot more to learn, and I just want to drive that home as I wrap up this class.